Hello, my name is Ali Sekman. I'm a professor of computer science at Tennessee State University. In this video, I'm going to talk about abstract classes, interfaces, and polymorphism, which is the second pillar of object-oriented programming languages. Therefore, it is crucial that you fully understand this lecture. Okay, so let's get started. This is for COM3110 Java programming class. And again, we'll talk about important concepts of abstract classes, interfaces, and polymorphism. And in order to understand polymorphism, we have to have a good understanding of abstract class and interfaces. So I'm going to give a little bit of motivation why we need abstract classes. Think about this class, student. This is nothing special. It is a class which has two data members, name and ID. And it has a constructor which initializes data members, and it has a method called register, which simply prints student registers. Nothing special about this class. Then I have another class called grad student, which extends student class. Remember, student class has two data members, name and ID. Grad student will have name and ID, and in addition to name and ID, it will also have thesis and advisor. And then grad student class is a constructor which takes two input arguments. It makes a call to superclass constructor with the first two input arguments and assign the third input argument to advisor. Notice that nothing is assigned to thesis. So when we create a grad student object, thesis will be initialized with its default value, which is false. And we have another method called register. Pay attention. This one is register method of student class. Register, no input arguments, return type is void, and access identifier public. Here, the same name, no input arguments, return type is void, access identifier is public. That means I'm overriding the register method of what? Student class. So a subclass can override the method, a method of it is superclass. Here, student is the superclass, grad student is subclass. Similarly, I have a class called undergrad student, which extends student. Student is a superclass, undergrad student is subclass. And in addition to name and ID that comes from student class, undergrad student has also another data member called classification. And it has a constructor which takes three input arguments. And the first line is a call to what superclass constructor with the first two input arguments. And I assign the third one to right here, classification. And I have another overridden method here because register, the same name, the same signature, the same return type, the same access identifier. Remember, when we override, we have to have the same signature, the same return type. The access identifier must be either the same or less restrictive. Since the student class has register as public, and there is nothing more, there is nothing less restrictive than the public, we must keep the public keyword here. So that's also an overwritten method. So here, what am I doing here? I am creating a grad student object, right? So here, let's go ahead and see, we have an object, grad student. When we have an object, we allocate memory space, if we recall. In this memory space, I will have what? 4 data members. One will be name, the other one will be ID, and another one was thesis, and the last one is advisor. We have to have those 4 for grad student. The first two will be initialized to John and 511, and advisor will be initialized to Ali Sekman, but thesis will be initialized to false. So here you will have John 511 false and Ali Sekman. Okay. Similarly, we have another object called undergrad student. So we will have here. Okay, let's do it here. Undergrad student. We allocate memory space for this. Again, here we will have name, ID, and this time classification. And name will be, in this case, Tracy. And then ID 750, and classification will be junior. Okay, so just to remind you, we didn't have to do that, but I just wanted to remind you. And then I'm going to make a call to register method via grad student object. Which register method am I going to call? Of course, I'm going to call the register method of what class? Grad student class. And I'm going to call register method of what? Undergrad student class in this case. If we get rid of those, and if you recall, this will print grad student register, the other one will print undergrad student registers. So this is the output that we are going to see. Nothing special here. My question to you is, we never use this register method right here. We never use this register method right here. So if I delete this, will anything change in this example? Nothing is going to change. Why? Because I have a grad student class. Instead of overriding, it means like this is like a brand new method of what? Grad student class. Again, this will be a brand new method of what? Undergrad student class. And I'm just calling it with grad student. So I'm going to call that register method of grad student class, and here register method of undergrad student class. There is nothing special that and we can safely remove it. Okay. But there are some cases that's going to be a problem for us to remove it, and I will talk about it. Okay. So this is the question. Can we remove register method from student class? Totally. Yes. Okay. But assume we removed it, and let's see this example here. Okay. This time, again, I mean, student class removed it, but grad student and undergrad student have register methods. Now, my question to you here is, we have those two objects, right? And just like before, I'm not going to write fully, but we have grad student object that points somewhere in the memory, and we have name, ID, thesis, and advisor. And then I have undergrad student that points somewhere in the memory, in which I have name, ID, and classification. So is this okay? Can I say student is equal to grad student? Remember, a subclass object is a superclass object. A grad student is a student. An undergraduate student is a student. A Honda is a car. A Chevy is a car. So a subclass object is a superclass object. Similar to like int is a double. So you can assign an int to a double. Similarly, you can assign a grad student to student without no problem. You can make this implicit casting right there. Okay. However, you cannot say grad student is equal to student because a student is not a grad student. So this is fine. In this case, what happens? Java creates a reference student. Okay, here student. It also points the same memory space as what? Grad student. Now, if I say student.register, I'm trying to make a call to register method of what class? Grad student. That's my intention because student points a grad student in the memory. However, Java will complain at this point. That will be compile error because remember, we only know where the objects points in memory at runtime. But at compile time, Java only checks the syntax. It will say, okay, I have student.register. I'm making a call to a method called register via student, and student is a student class object. Let me go to student class. Do I see register? No, then it will complain. So in this case, removing the register method of student class will cause a compile error. So how do we address this issue? Okay. So, okay, that's the statement that I put there. Even though we never call register method of student class, it's a syntax error if we do not provide header of register method. So this is how we fix it. What I do, I add register. I know I will never call it, so I don't provide an implementation here. And I define as abstract. So an abstract method is a method we only have declaration but no implementation. And if a class has at least one abstract method, it must be defined as abstract. So the changes that I did to the previous example, I defined as abstract, no implementation, no left and right braces, for example, and then I define this one as abstract as well. Okay, so now, just like before, everything is the same. I have grad student, and then I have undergrad student. I assign grad student to student. Now student points the grad student in the memory. And when I say register, it's gonna make a call to register method of what class? Grad student class, because student points the grad student object in memory. Here, when I say student is equal to undergrad student, I'm just gonna very briefly remind you, grad student, we have there, and then we have undergrad student, and then we have student, and student first points the same memory space as what? Grad student, and it's going to make a call to register of grad student. Then I say student is equal to undergrad student. In this case, student does not point here anymore. It points what? This memory space in which we have undergrad student. Therefore, it's going to make a call to register method of what? Undergrad student class. Okay. So look, I just have this statement. I have exactly the same statement, student.register, student.register, but one prints grad student registers, the other one prints undergrad student registers. Okay, so here student behaves as a grad student, but here student behaves as an undergrad student. So that's an example of polymorphism, because when an object behaves in different ways or polymorphically, that's an example of polymorphism. Okay. So what's an abstract method? Abstract methods have only definitions but no implementations. Well, if I have only definition but no implementation, why do I need a method such? Why do I need such a method? We did see why in the previous example. And who implements it? We also saw that in the previous example, a subclass will implement it. We defined register method as an abstract, and it was implemented in the subclasses grad student and undergrad student. Okay. Abstract methods are defined in abstract classes. Another class that extends the abstract class implements the abstract method. For example, the first one is an abstract method. It has no left and right braces here. It has only declaration. And similarly, this one has only declaration, but no implementation. Okay, here's another example. Think about this, class car. Why did I define as abstract? As you see, I have a method called size abstract. Class car has one data member, one constructor, and a method called toString, and an abstract method size. I have class Honda, which extends car, which has two additional data members. It has one constructor, and it makes a call to superclass constructor, as you see here. And it also has a method called size. As you see, size is an overridden method. The same name, the same input arguments, in other words, the same signature, the same return type, and the same access identifier here. And I'm overriding it because it is defined in the car class. You can say you are overriding, or you can also say you are implementing it. So that's what's there. And I have class Chevy, which has two additional data members, just like Honda class. It has a constructor, and it overrides toString method here, as you see here. Honda class did not override toString method, by the way. It has an additional method, is like a rock, okay? And it also overrides or implements size method. This prints luxury, this prints economy, okay? So here is what we have. I have a car. First, a car is null. So I'm gonna go ahead and show you this somewhere here. A car is initially null. Right there. Then I create an object, a Chevy. I'm not going to write fully, but I have a Chevy object. It will point somewhere in the memory. What am I going to have in the memory? You can tell me. Chevy has superclass cars, so I will have make, model, and year. Okay, assume I have those. I'm not going to write all of them. Then I have a Honda. A Honda also will have make, model, and year. Okay. Then here is the crucial part. Let's look at this. A car is equal to a Chevy. Yes, I can assign a Chevy to a car. Why? Because a Chevy is a car. Okay. Therefore, now a car will not point null anymore. It will point what? A Chevy object right there. And then when I say a car.size, which size method? In memory, a car is pointing to what? A Chevy object. So it's going to make a call to what? Size method of Chevy object, and it will print economy. And then I say a car is equal to a Honda. That means a car is not pointing here anymore. It points right there. Therefore, when I say a car.size, it's going to make a call to size method of Honda, and it will print luxury. And when you look at this line and this line, they're exactly the same, but they behave differently. Why? Because a car first points to a Chevy, and then a Honda. That means a car behaves polymorphically there. Okay, here a car behaves as a Chevy. Here a car behaves as a Honda. So an abstract class is a class that may have explicit or implicit methods that are declared but not implemented. When I say explicit, that means you may have it within the class. When I say implicit, you may be inheriting it from your superclass. And if a class has an abstract class as it is superclass, assume that you are the class and your superclass is an abstract class. You must implement all of the abstract methods of your superclass. Otherwise, you must be an abstract class as well. You cannot create objects of abstract classes. When I say you cannot instantiate, this is equivalent to saying that you cannot create an object of abstract class using the new keyword. Interestingly, an abstract class may or may not have any abstract methods, but of course it makes sense that it should have at least one abstract method, but it's not required. And the purpose of abstract classes to be used as superclasses only. Therefore, you cannot create objects directly. Any class that has any abstract method in it must be defined as an abstract class. Here is an example. Class test is abstract. It has two abstract methods, method 1 and method 2. As you see, they are abstract because we have declarations or definitions, but no implementations, and it has a regular method. So class test has two abstract methods and one regular method. And since it has at least one abstract method, I have to define it as abstract class. Again, I repeat, if a class does not override all the abstract methods of its abstract superclass, it must also be declared as abstract. Otherwise, you get a compile error. Let's look at this. Here I have a class 1. It has 1, 2, 3 abstract methods, method 1, method 2, method 3. And it has a regular method, method 5. And I define the class abstract. So there are no issues here. This is perfectly okay. Okay, this is okay. And then I have class 2 extends class 1. When I say extends class 1, either I will implement all of the abstract methods or I will define this class as abstract. In this case, I define as abstract. Why? Because I'm implementing only the first method, method 1, but I am not overriding or I'm not implementing method 2 and method 3. Therefore, I define this abstract. So in this case, this is also okay. However, the same example, if I did not have that abstract keyword here, then it will be a compile error, okay? And this is little, I guess, yeah. So this has method 1, method 2, as two abstract methods, and method 3 is a regular method. Okay, so when I say test2 extends test, what do I guarantee? I guarantee that I'm going to implement those two abstract methods, but I implemented only one of them. Since I have one unimplemented abstract method, I must define test2 as abstract. Okay, so this is an error. Why? Now I have an abstract class test, and I'm trying to instantiate it using the new keyword. That's an error. You cannot create objects of abstract classes. All right, let's see this example. Abstract classes can have constructors. I mean, why not? I mean, because abstract class will be a superclass for another class, and that class subclass may make a call to superclass constructor, even though we don't use a new keyword. So it makes sense that we have constructors in abstract classes. See, if a subclass extends the abstract class, then the subclass's constructor can make a call to the abstract class's constructor. So therefore, it's okay. Okay, this is also okay. Look, this is a class test. It has a method 1, which is defined and implemented. It doesn't have any abstract methods, but we can still use it as an abstract. What will be a possible reason? Well, if there's a reason that we don't want anyone to instantiate this class test, we can make it abstract, for example. So here is the question. What do I need to do in order to make this class compile, or this program compile? First of all, what is the issue? Here, class is abstract. It has an abstract method, but bam, we have a method which is implemented, as you see, but we still say abstract. That's the issue, right? If I remove this abstract keyword from here, I will be fine. Why? Because I have a class that has two methods. The first one is abstract, the other one is not, and the class is defined abstract. That's perfectly okay. All right? So, or another way is if you remove the implementation from here, all the way here, remove it and put a semicolon here. That means make football an abstract method, then you will be also fine. Okay, so it says select 2 for correct uses. I have a class test, which is abstract, which has an abstract method, method 1, and which is a regular method, method 2. So now, is the first one correct? Public abstract class test2 extends test. I define a class test2 which extends test, but it does not implement method 1. What do? I define it as an abstract, then I'm fine. Test2 does not implement method 1, but it is defined abstract, so we are fine. How about this one, second one? Test2 extends test, and it implements method 1, as you see here. Method 2 is already a regular method, so there are no issues. So this is also fine. How about the third one? I say public class test2. This time, instead of extends, I use implements keyword. You don't know implements keyword yet, but you're going to learn in a minute. So you cannot have implements. And here you have public class test2 extend test. You say you're going to implement method 1, but you did not implement because you don't have left and right braces here. So 1 and 2. So what's an interface? An interface is nothing but an abstract class whose methods are all abstract. In a regular abstract class, you may have some abstract methods and some non-abstract methods, but in an interface, all the methods must be all abstract. And another thing, all of the methods are by default public and abstract. Even though you don't use public keyword, even though you don't use abstract keyword, by default, all the methods of an interface are abstract. Similarly, all the constants of an interface are public, static, and final. If you have a data member in an interface, that means it is public, static, and final by default. In Java, a class can extend from only one other class. For example, we said Honda extends car, Chevy extends car, grad student extends student. Only one super class. However, in Java, even though you have one direct class inheritance, you may implement more than one interface. I will explain what it is. A class that implements an interface must implement all of its methods. Why? You remember, if an abstract class is If you extend an abstract class, you must implement all of it as abstract methods. Well, if you say you're going to implement an interface, we know that all the methods of an interface are abstract by default. You must implement all of it as methods. Otherwise, you get a compile error. If you use implements keyword, you guarantee that you will implement all of the abstract methods. Here is one first example. I have an interface. So far we had class, but now we have a new keyword interface. And the common convention, it doesn't have to be, interfaces typically start with capital I. Okay, it does not have to. So interface iRobot constants. So this interface has 3 data members: height, radius, and forward. It does not have any methods, but by default, this is public, static, and final, even though I don't have those keywords here. Don't forget that. Then I have interface iRobot functions, and it has 3 methods defined: get, sonar, drive, turn. And by default, they're all public, static, okay? Now I say class robot, okay? Implements iRobot functions, comma, iRobot constants. What does that mean? When I say implements iRobot functions, I guarantee that I'm going to implement get, sonar, drive, and turn. Do I do that? I implement get, sonar. I implement drive. But do I implement turn? No, then this will be an error, okay? I say comma iRobot constants. Well, even though iRobot constants does not have any methods, with this, I will have access to height, radius, and forward. For example, when I use forward here, I don't know what it is, but since it comes from iRobot constants, I know forward means 50, okay? All right, I hope you understand that. Here is another example. I have interface 1. Remember, an interface is nothing but an abstract class. An abstract class is a class. Don't forget that, okay? So it has method 1, method 2. They have definitions, but no implementations. Again, this is public static here. And I say class 1 implements interface 1. Okay, implements interface 1 means I guarantee that I'm going to overwrite method 1. Do I overwrite method 1? The same name, the same input argument, the same signature, the same return type. Do I have to use public here? There's no public here, but do I have to have public here? Yes, because even though there's no public here, as I said, Java is going to go and put public abstract keywords for us, okay? So therefore, it is a public method, and when we override, it must be either the same access identifier or less restrictive. Since this is public, it must be public because there is nothing else more less restrictive than public. So this is fine. And what method 2? I overwrite method 2 as you see here. Again, I use public. So I am perfectly okay. Class 1 implements interface 1. Here, what do? I create an object of class 1. Okay, so here I create an object of class 1, obj1. It points somewhere in the memory. And then I say obj1.method 1. Well, obj1 is class 1, so it's going to make a call to what? Method 1, right here. And it will say that the input argument is, as you see, the input argument is 10. So it will print input argument is 10. Then I'm going to say the second method returns. This time I'm going to make a call to what? Method 2. This time I'm going to make a call to method 2 right there, and with 5 and 10. And it's going to multiply a by a, 5 times 5, 25. Okay. Of course, the point here is what? Class 1 implements interface 1. I don't use extends. A class implements an interface. Okay, how about this one? I have interface 1. Again, method 1, method 2. I have interface 2, method 3. This time I say class 1 implements interface 1, comma, interface 2. When I say implements interface 1, what do I guarantee? I'm going to implement method 1 and method 2. Here's method 1 and method 2. I implemented them. When I say implement, I overwrite them. With interface 2, I say class 1 guarantees to implement what? Interface 2 methods, which is only one, method 3, and I am overriding that, and I am perfectly okay. So again, public must be here because they all have public keyword or access identifier implicitly by Java there. And when I say override, the same signature, method 1 int, method 1 int, the same return type void void, and either the same or less restrictive. Since this is public, I have public. Here is another one, and I have interface iRobot. This time I have two constants. Remember, we have public static final here, public static final here. I have public static here because all the methods are public static. And I have interface 2. Oh, look at this. This is the whole point that I'm trying to tell you. They're all the same. I have 3 interfaces. This has nothing there. This has public static final. This is public abstract. This says public static final, only static, only public. So you can have any combinations of public static final for data members, and you can use any combination of public and static for what? Methods. For example, even if you say static, Java will go and put public for you. Even if you have public, Java is going to go and put abstract for you. They are all the same. What happens if two interfaces have the same methods with the same signature and return type? Let's see with an example. Look at this. Interface 1 has a method, method A. Interface 2 has a method, method A. It's the same signature. What's the signature of this? Method A underscore int, method A underscore int, the same return type, right? Now I say class 1 implements interface 1, comma interface 2. With implements interface 1, I guarantee that I'm going to implement method A. Do I implement method A? Yes. With this, I guarantee that I'm going to implement the methods of interface 2, which happens to be the same method. So implementing once is going to make me keep my promise that I implement this guy and this guy. So I will be just fine. Can I implement twice? Obviously not. For example, if I can have public void method A again, this is going to be improper overloading in class 1. Because you cannot have 2 methods with the same signature in a single class. That's exactly what I was trying to say. Oh, okay, this is different. What happens if 2 interfaces have the same methods with the same signature and different return types? Okay, let's go back. So what if I change this to int? Or not that one. I'm going to change this one to int, let's say. Okay, so when I say class 1 implements interface 1, I guarantee to implement method A. So this will be fine. This will be fine, right? Then I say I'm going to implement interface 2 method A. So therefore, I must have something like this here. I'm going to put it here, public int method A int A something something. But then we will have a problem. Why? Because look at this. In class 1, I have a method, method A. I have another method, method A. What is the signature of this? Method A, method A underscore int. What's the signature of this? Method A underscore int. Remember, in a single class, you cannot have 2 methods with the same signatures because that will be improper overloading. So this will be a problem. Okay, very important. A class extends another class. A class implements an interface. How about an interface? Will an interface extend another interface or implement another interface? Well, an interface extends another interface. Because if I say interface implements another interface, I guarantee that I'm going to implement all the abstract methods of the super interface. But if I implement any of them, I will have some implemented methods in the sub interface, and that will be a problem because an interface cannot have any implemented methods. Let's look at this. I have interface iRobot constants. I have this iRobot constants have just the constants, as you see, public static final. And that interface iRobot functions. This is an interface and it extends another interface. You see that? That means iRobot functions will have 3 abstract methods and it will inherit those constants from what? It is super interface iRobot constants. Then when I say class robot implements iRobot functions, I guarantee that I'm going to implement those 3. I implement 1, 2, all of them. Are they proper implementation? Yes, the same signature, the same return type, and the same access identifier. And here, when I say forward is not directly defined in robot, then I will go to iRobot functions. And it is not directly defined in iRobot functions, then I will go to super interface, and here forward is 50. So forward is actually 50 right there, okay? Okay, here is another example. I have interface iActuator, which has a method called method1. I have interface iSensor, which has a method called method2. And I have interface iRobot extends iActuator, comma iSensor. If it was a class, you cannot have double classes after extends because a class can extend only from one class, but an interface can extend from multiple interfaces, no problem, okay? This is important. If extends keyword comes after an interface, you can have multiple other interfaces as super interface. And this says method 3. So what does this say? iRobot has one abstract method, method 3, and then another one, method 2, that comes from this, and another method, method 1, that comes from this. So anybody who will implement iRobot must implement all those 3 methods. How about this one? Class cSensor implements iSensor. Well, is that okay? Sure. iSensor has one abstract method. I have to implement it, and this is what I did. The same signature, the same return type, the same access identifier. And I say the same access identifier because I know by default this is public. So this is perfectly okay. How about this one? Class cRobot extends cSensor. That means this is superclass, and at the same time implements iRobot. This is fine. You can use extend and implement together. You can extend. Since I'm extending cSensor and implements iRobot, when I say I implement iRobot, what do I guarantee to do? I guarantee that I'm going to implement method 3 and then method 2 and what? Method 1. I have to implement those 3 methods. And I extend cSensor, but cSensor already extended iSensor, and it already overridden what? Method 2. It already implemented method 2. Here, no problem, right? This is perfect. I'm implementing method 1 right there. And this is also perfect. I'm implementing what? Method 3. And here, I have 2 purposes. First, I am overriding, because this is cSensor. As you see, this is the same signature, the same return type, the same access identifier. That means I'm overriding method 2. Why overriding method 2, I also keep my promise that I was going to what? Implement method 2. Then here, this is a little tricky. First, I create, look here, new cRobot. That means I created a cRobot object here, okay? This is a cRobot object in memory. Did I name it? No, but I know it is. First of all, if I have this C, okay, hold on. If I go ahead and remove this, will I have a problem here? Yes, because cRobot is a subclass object, cSensor is a superclass object. So a student is not a grad student, right? A student is not a grad student. Wait a second. Let's think a little bit about here. Well, yes. I mean, assume that we don't have this. This will be still okay because we know that CRobot is a subclass object, and I can assign a subclass object to superclass object. But the question here is that, oh, this one points where in the memory? It points a CRobot object in memory. When I say method 2, which method 2? Is going to be this method 2 or is it going to be this method 2? Since in memory it points to a CRobot object, it's going to make a call to which method 2? This method 2, and it will print here 2, not here 1. Okay, just to show you as an example. What's an adapter class? Well, when you have an interface, sometimes it may have too many. Yeah, sometimes when you have an interface, you may have too many abstract methods. And when you say, I'm going to implement it, you have to guarantee to implement all of them. And you may not need many of those abstract methods. So with adapter classes, what we do is we define a class called adapter. We say implements interface 1 in this case, and we implement all of them in a dummy way. For example, here, int method 1, I say return 0. The most simplest way. And I say method 2, it returns 0.0, method 3, which is not supposed to return anything in the left and right braces. Method 4 returns 0 because that's int. So I define them in the most primitive ways or implement them. Then instead of saying class test1 implements interface 1, I say extends adapter 1. And I overwrite only the methods that I need. For example, if I need only method 1 in class test1, if I don't need any of those methods, if I don't need any one of those, I just use the default implementation that comes from adapter 1, and I just overwrite only what? Method 1, because that's the method that I will need. Okay? However, if I didn't have this way, if I had class test implements interface 1, I have to overwrite this one the way I want, and then I have to implement the rest as well. So adapter classes may give you flexibility in case you may not need all the abstract methods of the interface. Okay. Well, pay attention. This is adapter class, implements interface 1. What happens if we do not have public keyword? Of course, that's an error, right? Because this is public static by default. I must have, when I overwrite, I must have either the same access identifier or less restrictive. Since this is public, I must have public. Okay, is there a problem with this? There's a problem with this. Why? Because by default, this is public, static, final. If it is final, it must be initialized. All the final members must be initialized. Here, X is not initialized. But if I have X 10, for example, this will be fine, okay? So this cannot be left like this without initialization. Okay, how about this? These two are exactly the same. I have nothing in front of it. I have only static, that's fine. Java is gonna go and put what? Public, final. This is only public, Java is gonna say public, static, final. This is only final, we'll put public, static, final. It's public, static. You can have any one of those keywords. You can have either all of those, public, static, final, or any combination of those three, or none. Java is gonna take care of it for you. How about here? And again, if a method is defined in an interface, it's always public abstract. If there is nothing here, Java puts public abstract. If you have only public, Java will take care of abstract. If you have only abstract, Java will put public for you. So you don't have to put any one of them. They are exactly the same. Okay, let's look at this. I have a class C-sensor, which has only one abstract. It's an abstract class, as you see. And I have an interface with one method. So C-sensor is an abstract class. This is an abstract, this is an interface. So which ones are correct? Okay, define a class called CRobot that inherits from C-sensor and iRobot. What does that mean? That means CRobot will extend from C-sensor and will implement iRobot, okay? So Is this correct? I have public class CRobot extends CSensor implements iRobot. When I say extend CSensor, I guarantee that I'm going to what? Implement method. Okay, do I implement this method? The same signature, the same return type, either the same or less restrictive. Protected, I have public, which is less restrictive, so I'm fine. When I say implements iRobot, what do I guarantee? I guarantee to implement this method. And do I do it? Yes. Remember, this was public, so this is public. So this first one is fine. How about the second one? What's the problem with the second one? When I say CRobot extends CSensor, I guarantee to override this. I did override it correctly. Protected, protected. But when I say implements iRobot, I have to implement this. Well, I implemented it, but this is public here. I cannot have more restrictive. So this is incorrect. Well, how about this? In this one, public class CRobot extends the same thing. This time I have none. Well, there are two issues. One, when I say extend CSensor, this is protected. I cannot have none because none is more restrictive. And I cannot have none because this is public. It must be at least public. Well, you cannot switch implements and extends keywords. Okay. Extend CSensor implements iRobot. I mean, this is total nonsense here. There is no such a call. Okay. Again, this is not proper. These are not proper either. Final classes. If a class is final, that means it cannot be superclass. No other subclasses, no subclasses of this class exist. If the name of a final class appears after extends keyword, that's a compiler. My question to you, can a class be final and abstract? No, because if a class is final, it cannot be superclass of another class. But if a class is abstract, that abstract class should be superclass of another class so that that class can implement abstract methods. So that's a contradiction, okay? So final means no subclasses. Abstract means a subclass will implement the abstract method. So if I make it final and abstract, there is no way for anybody to implement the abstract methods of the abstract class. A final method cannot be overridden. In a class, in a regular class, you can have a final method. That means that method cannot be overridden. If your class is final, all of the methods are by default what? Final. A method cannot be final and abstract for the same reason. If you have an abstract method, if you have a method abstract, that means someone else will implement it. But if you make a method final, that means no one else can implement it. That's a contradiction. Here, I have class test one, I have method one final, test extends test one, and I'm overriding it. The same signature, the same return type, the same access identifier, but since it's final, that's a compiler. You cannot override it. Okay, let's look at this. The only difference is that if you have a final method which is defined private, then you can override it. Because private means it is accessible only from the super test class in this class. So for final, you can override it with the same signature, the same return type with less restrictive. However, if it is not private, you cannot override it in the subclass. Native methods. I don't know if you will ever need this, but I just wanted to introduce them. They are called foreign methods. Their implementations are defined in another programming language, such as C or C++. And you need to use static block to load the library first. For example, if I have a method one, I define it native. That tells me that method one has no implementation in this class. Method one is coming from a library, which is developed in another programming language. And I just load that library first with a static block. Then I make a call to that method, native method, as if it is my own method, okay? So native methods are defined in another programming language. And first you load the library in a static block, because the static block will be called before you make a call to method one here, okay? Polymorphism. So let's have a little bit formal introduction. an object may behave differently or polymorphic depending on what it really points in memory. Okay, here is one example. And I have 4 classes: car, which has only 2 string methods, and this Chevy class has a size method. Okay, Honda class size method, BMW has size method. Okay, so let's pay attention. I have size method for what? Chevy class. I have size method for Honda class. I have size method for what? BMW class. Do I have size method for car? No. Okay, I don't have that. And each size method does something similar. Size method of Chevy prints economy, size method of Honda prints luxury, and size method of BMW prints super luxury. But finally, I mean, they all print something, right? Okay, let's keep this one in mind. And now here, what do? I create a Chevy object. This points somewhere in the memory. I have a Chevy object. This points somewhere else in the memory, and this points somewhere else in the memory, okay? So I have 3 objects. Then I define 3 methods called method Chevy, which takes a Chevy object as input and makes a call to the size method via what? That object. I have another method, method Honda, which takes Honda object as input, calls size method. Similarly, method BMW makes a call to basically method Chevy, method Honda, method BMW. The whole purpose is to call the size method of the corresponding classes. Okay? And I make a call to method Chevy. I send a Chevy as input. That means when I say C.size, it will be a Chevy.size. Here, this will be a Honda.size. This will be a BMW.size. Practically, I had 3 different methods just to call the size method of the corresponding class. This seems to be inefficient, right? What if I had not 3, but 20 different car classes? Would I have 20 different methods? Method Chevy, method Honda, method BMW, method Ford, method GMC, and so on, which makes no sense, right? So I can fix this problem easily with a better or more efficient approach. What I do here, this time, I have the size method here. I have the size method here. I have size. And remember, I didn't have size before, but I added an abstract size method to class car, and I define my class car abstract as well. Okay, so let's keep this in mind, and let's go to next slide. The same thing. Now, look at this. First, I have a car. A car points null. Right there. And then I have a Chevy. A Chevy. A Chevy points somewhere in the memory in which we have a Chevy object. Similarly, a Honda. And then similarly, a BMW. Okay? So I created them. Then now I say a car is equal to a Chevy. Yeah, a Chevy is a car, so I can assign a Chevy to a car. In this case, what happens here, this connection will be gone, and a car points right here. Okay, let's keep that in mind. Then I have a method which takes a car object as input. And via that object, it makes a call to the size method. Here, what I do, right here, this pass right there as input. If you recall, passing an object reference as an input to a method means they will point the same memory space. This time, obj will point the same memory space as where a car is pointing to. And as you see, obj will be pointing to where? A Chevy object in memory. When I say obj.size, it's going to go and make a call to size method of what class? Chevy class. Okay? So it's going to print economy. All right. Then I have this, a car is equal to a Honda. Well, a Honda is a car, I can do that. In this case, it will not point here anymore, but it will point where? A Honda. And then I make a call to, again, this method here, right? Right there. And obj will point the same memory space as a car points to, in this case, a Honda. When I say obj.size, it's going to go and make a size method of Honda. It will print luxury. And then the last one. This time, a car is BMW. That means a car will point now BMW. And then obj will point there. And then when I say size, it will print, it will use the size method of BMW. It will print what? Super luxury. So isn't this nice? What did we do? We define only one method, and it makes a call to size. But while we are calling this method, we make sure that a car points to an appropriate object in the memory. So from this point on, we don't have to have 20 different methods. A single method will take care of this. So a method, a car, as you see here, this one, that one, that one, are exactly the same, but they behave differently depending on where a car points in memory. Even better, think about data structures. I mean, data structures is a very fundamental concept in computer science, as you see, as you know. Some of you may have taken data structures class, maybe not, but think about this. A vector is a list. A linked list is a list. An array list is a list. A stack is a list in data structures. So what we can do, we can define list as an interface, and then we can have classes called vector, linked list, array list, for example, or stack as classes, and each can implement list. In fact, that's the structure that most of the programming languages use. But I'm going to make a dummy interface and a dummy class for you, of course. Okay. For example, I made this public interface list. I can define list as an interface. I may have add method, and then maybe an overloaded add method. As you see, this has signature add object. This has signature add int object. May have clear method, contains, get, index of, remove size. These are all data structures related functions. For example, if you want to clear the whole data structure, you can have clear method. If you want to add an item, you can make a call to add. And if you want to see if it contains a particular object, you make a call to contains method, and so on. So in good object-oriented programming practice, you define list as an interface, okay? And don't forget, they are all implicitly public and abstract. And then I define, for example, class vector. And I say vector implements list. When I say implements list, I guarantee that I'm going to implement 1, 2, 3, 4, 5, 6, 7, 8 methods. And do I implement them? Yes, 1, 2, 3, 4, 5, 6, 7, 8 methods. For example, the first one is implemented. Of course, I'm just doing dummy implementations. Second one is implemented. This returns true because this is Boolean, this is void, nothing. And I just particularly add something very fundamental here. This says vector class clear method. So simply this will, if anybody makes a call to vector clear method, it's going to print this one. And it has some other dummy implementations, okay? And then I have, of course, all of them must be public for the same reason I multiple times reiterated. Then I have public class array list. This time array list implements 8 of them, but they implement differently. For example, clear method this time says array list clear, array list class clear method, okay? And now what do? I create a vector object, as you see here. This is a vector object. And I refer to it with list 1. Can I do that? Yes, a grad student is a student. A Honda is a car. A vector is a list, right? Because list is the superclass or super interface. So since a vector object is a list, I can create that object first and assign it to what? List 1, okay? So that's what I do. So list 1 points somewhere in the memory in which I have a vector. and list2 points somewhere in the memory, I this time have what? An array list. When I say method, and I define a method which takes a list as input. It does not say vector as input. It does not say array list as an input. It says list as an input. What does it do? It makes a call to clear method of the input argument. So in this case, I make a call via list1. So when I say clear method, it's going to make a call to clear method of what? Whatever I have in the memory. Since I have a vector in the memory, it's going to make a call to clear method of vector class plus a vector class clear method. Then when I make a call with list2, this time clear method of what class? Array list, because list2 points to an array list. Okay. So this is an example of polymorphism 2. As you see here, this method, okay, with one method definition, we were able to take care of the appropriate class clear method call, depending on what obj points in the memory. Just as a note, Java has its own list, vector, array list, linked list, stack located implementations located in java.util package. Here I'm just making my own dummy list, vector, and array list classes so that we can understand the polymorphism here. All right, so I'm done with the polymorphism, abstract, and interfaces. Just to remind you a couple of previous things that we discussed, and this is an example. I have class test, which has a constructor, default, there's another constructor, and there's another constructor. So there are 3 constructors, okay? Here, I'm creating an object of myself, obj. In the memory space, when we do that, we will have x10 as hello, okay? Right, these 2 data members. But which constructor am I calling? I'm calling the default constructor. So this will take me there to default constructor. And then the first line is to call to what? One input argument constructor, which is a string. It's going to take me to this constructor here. And S will be what? There. And the first line is a call to this constructor. And this is 80. This is how are you? Then 80 will be X. This will be 80. And this will be how are you? Okay. And then this is done. This is done. It will print 2 input constructor. So on the screen, we will see 2 input constructor, and we'll be done with this constructor. That means I'm done with this line, and it will go and print 1 input constructor. That means I'm done with this constructor. That means I'm done with this, and it will print default constructor. So 2 input constructor, 1 input constructor, default constructor. Once I'm done with it, it's going to print S. S will be what? Go to the memory space where obj points to and print how are you, and go to the memory space where obj points to get X, which is 80. So it's going to print that, and then how are you? Wait a second, which one is that? Well, I guess I was supposed to switch this to right there. Okay, and here is another example, and there is a problem here. What's the problem here? Look here, this is a superclass constructor, so subclass constructor, Honda. Since the first line is not an explicit call, Java is gonna go and put here what? Super. That means we'll go to the superclass car and make a call to superclass default constructor. But do I have a default constructor? No. Since I have one constructor that takes an input argument, since it has at least one constructor, Java is not going to create a default constructor, and it will be a compile error. I hope you get this. A very important concept of polymorphism, abstract classes, interfaces, you must feel extremely comfortable with those concepts. So far we have concrete classes, abstract classes, interfaces, and we also talked about adapter classes and some other important concepts. I hope you do enjoy the video. Thanks.